What's going on, you guys? Welcome back to the channel, and today's video is going to be how to build this Flappy Bird style endless runner jumper game in Python using PyGame. Alright, so Flappy Bird was this like crazy viral iOS game from my high school days that is a ton of fun, super popular. You've probably heard of it. If not, look it up. It's awesome. And today I thought it'd be super fun to do a tutorial on how to build that style of game. And if you're familiar with the channel, we do a ton of stuff in Python, and I like to use PyGame for little computer games. So as always, start by importing PyGame. If you don't have it installed, you might need to run pip installer. I'm using the PyCharm IDE, and if you have PyCharm, there's this nice feature. You can hover over something. If it's not installed, it'll try to install it for you. So as always, import PyGame, and then the first step once you do that is pygame.init, and that initializes PyGame. It lets you use everything inside of the PyGame module. And then the next thing I do is I create my overall screen size. So when I was playing around with this, 900 by 500 felt pretty good on the computer. If you were trying to design something that was a little better for mobile, you might want to flip those and do like width 500, height 900. I like this a little bit more. And then so I make the width and the height in a variable so that I can use those later on in my program. But then the next thing to do is just create your screen, and that's by doing screen equals pygame.display.setMode, and then you give it a size in these two square brackets. You give it width followed by height, and since I have those in variables that I called width and height, that's all you have to do for it. And then another thing I like to do is make an FPS. This is pretty standard for any game that you're going to build. You want to control the speed at which it runs. So you set up two things. You create a variable for a timer, and I just call it timer, and that's pygame.time.clock. And then you define an FPS variable, which I'll set up as 60. And to do that, so inside of your main game loop, so you want to create this loop where as long as the game is running, and you have to create a running variable, set it equal to true when your game starts up, and while running you do timer.tick at your FPS. So you could skip an intermediate step here and just punch a 60 in there, but FPS is kind of nice to have in a variable, and you can play around with the speed to see how that affects your gameplay, but I'm going to do it this way. So you do two things right when you set up this timer or this main game loop. You do timer.tick and then screen.fill. And if you've seen any of my videos, you've seen I don't like typing in RGB values every time I need to reference one. I like creating a library in the beginning and creating colors. And then when I need to enter a color, so like screen.fill, I can just type the color black. And all I have to do is think about what makes each color right in the beginning. So I'll add a few more while I'm creating black. I'll create just white, and these are 0 to 255 RGB values. You can look up specific ones online if you're like, oh, I want to see a gold, or I want to see a specific gray or purple, whatever. These are just kind of three standard ones to get me going. I'm gonna do Flappy Bird in space, so black, white, and gray will get you most of the way there. Okay, so right now we've told our timer to play during the game loop, and we've done screen.fill with a black background, which will be good for space. And we have to do a couple more things before we get the game to start. And I'm going to create something. I always call this event handling. So it's for event in, it's not event.type yet, for event in pygame.event.get. So this is their built-in function in the PyGame module to just get everything that's happening to your computer. Keyboard clicks, mouse button clicks, text inputs, anything going on your computer is built into the pygame.event.get. So I call everything underneath that event handling. But then what we want to do just to get the game started is if event.type equals and then pygame.quit, and this is specifically the X button in the top of your window when you open a screen up, and all we're going to do is if you click that button, we're just going to set running equal to false, right? Because if we don't have this bit of code, this is an infinite while loop. There's no code that's going to let you exit that while loop, and your computer's going to freak out because it doesn't like processing the infinite. And then the last thing, just to get our screen to actually show up as black and stay up, is you add pygame.display.flip, and then with no indentation, so at the very lowest level of indentation, you just add pygame.quit. And if I run this, it should be everything we need to do. Let me see what oh, it's because you don't put these parentheses at the end of quit. My mistake. Okay, so now we just have a window. Kind of looks like space, not really. But let's go ahead and draw the player on so you can kind of see what's going on. And since the player, if you're familiar with Flappy Bird or you saw the kind of intro, the way we control the players with the space bar, and he's constantly jumping, so we want to make his x coordinates, and we'll do y coordinates, we want to make the coordinates variables. So I'm going to come up, and under these kind of constants that I've made up here, I'm going to create like a variable library. And I'll just start by making a player x and a player y, and I'll just set them equal to 0 so that I can start using them, and then we'll actually take a look at what makes sense. So I'm going to draw the player in a function. You could put all the instructions for drawing your player right here. I've done that in a few past videos, but because I want the player to be kind of a fun looking character with like a beak, because it's kind of a bird, an eye, a jetpack, and some flames, I'm going to put all of that in a function just because it would muddy the main game loop, and it's more Pythonic to isolate code into functions when you can. So I'll create a variable, I'll call him the player, and what I'm going to do is set player equal to a function that I'll create called drawPlayer, and we're going to pass in the player x and player y variables because we need those so that the function knows where to draw them. Okay, so let's come up here and actually create that function. We called it drawPlayer, and I'll just call these xpause and ypause. Typically, if you want to modify variables inside but you don't want to change the outside world, or you want to use them, I recommend giving yourself a different name in here than outside world. You could call this player x and this player y again, but I wouldn't. So return, and we'll just return player so we remember to pass something back. But now what we're actually going to do in here, let's just start by making the player. Okay, so he'll be a rectangle, pygame.draw.rect, and you may have seen the beginning and thought it looked kind of spherical. That's because we're going to do a rounded rectangle, but I like using the pygame.rect collision tool, so we're going to do it this way. I'm going to put him on the screen. It's going to be white. I'm going to put the player at a position of player x, player y. So when you define a rectangle, you give it 4 arguments. If you're not familiar, it's x starting position, y starting position. And the way PyGame uses coordinates is that'll be the top left of your character. So then you give it the width you want and the height you want. And I think it looks pretty good just in a 30 by 30. But you certainly can change that around if you want. Okay, so we'll do 30 by 30, and then the next 2 arguments are width. So if you wanted it to be a hollow rectangle, you would give it like 2 or 3, that would be border width. But if you want it to be solid, put a 0 there. And then I'm going to give it a really rounded edge. So I'm going to do like 12. And you'll see when we load this up that that actually that may be all we need right there. And it's not player x, player y anymore. I just talked about that. It's xpause and ypause. So careful that you don't reference the outside world variables if you named them something different. Okay, and actually, let's just call this play because we called it player and I gave you the whole spiel about not using the outside world. So let's just check that out. All right, and you can see the little guy here, and right away you see what I was talking about. We make him 0 and 0 initially, and that's not really great for this game. So why don't we move him down and kind of into the middle of the screen. We're 225 would put us right around the middle of the screen. And let's just see how that looks from the X direction. It'll be kind of far back to the left. But for a runner, this is about right. That's kind of what you want. So, okay, it's just a ball. But like I said, we want this to be a fun little character. If you think about Flappy Bird, there's not a lot going on in your bird, but it's cute, right? It's a few pieces. So let's go ahead and make another piece that we'll call mouth. And actually, I'm going to put it behind the player because I'm going to just use a circle for the beak. And it's going to be something that I want the majority of it to be hidden behind the player. So let's take a look here. We're going to put on the screen, we're going to make it gray, and now for a circle you just give it the X and Y coordinate of its center point, and then you give it a radius. So we'll say for X and Y spot we want it to be X pause and Y pause, but that would put it right in the middle of the player. Let's move it to the right 25, so that'll move it pretty close to the right edge of the player. And let's add 15, so that'll move it down from the top of the player a little bit. So that's pretty good. And then let's just see how it looks with a radius of 12. I'm hoping this will be like a gray, let me get rid of that, like a gray beak sticking out. And you can see, I think that looks pretty good. You can play around with this if you want. You can just use a whole bunch of lines and rectangles and circles and make a complex character if you want. I'll add an eyeball as well. I'll just call that eye. It's going to be another circle. So I'll copy this down, but we're going to draw a little black circle on a white rectangle for our player. So we'll make the eyeball gray or black. And why don't we put it 24 is probably pretty good. Y position of, we don't want to move it down so much anymore. Let's just move it down 12. And I want this to be a lot smaller than the beak. So let's check it out at 5. Okay, and now this part is where you should have some fun, make it your own. You don't just have to follow along line by line. I'm making a little character that when it jumps, I'm gonna think, oh, that's fun, and I drew that piece by piece. You could even import like a JPEG or a PNG. I've shown how to do that in past videos. Check out the Halo tutorial series or a few others where I've actually imported images to use. But so that's the eye, and then I think the last thing I'll do, I'll give him a little jetpack. Because like I said, I want it to have some flames. That's not something the original Flappy Bird has, but I think it could look pretty sweet. So we'll do screen. We'll make this one white, and we will put it, let's see. So we got to give it the 4 coordinates again, because we're going to do a rectangle for the JPEG or for the jetpack, and that'll be X position, and then we'll move it back some. So -20, and then Y position. And we'll do Y position. Yeah, we'll just leave it at Y position, top left. That's fine. And then we'll make it 18 wide and 28. So it's almost the same size as the player, but a little bit behind him and not quite as wide. And we'll make it hollow, and we'll still round it off. So let's check that out. Or solid, and we'll round it off. That looks okay. Actually, I do want to make it hollow. So we'll give it an edge width of 3, round it a little, and it looks like he's got a jetpack on. Once we get to handling player movement, we'll add the flames. We'll do that a little bit later, but we've been drawing the player for long enough. Let's get into the actual action. Okay, so I think the next thing we should do is make it to where if you press the space bar, the player is going to jump. So to do that, we do if event dot type. And then there's going to be a new event type, and it's going to be PyGame.keyDown. Okay? And now that's checking for any key on your keyboard that could be pressed. And we'll say if event.key is equal to, and then it's PyGame.k space. And that's just checking the space bar to see if it was pressed. Okay? And if the space bar is pressed, we're going to create a new variable called yChange that we'll use to affect the player's y coordinate. And we'll set yChange equal to a variable that we'll call jump height. And the reason I'm putting that in a variable rather than just saying like -10, so we got to make 2 new variables based on what we just did. To start, we'll do yChange is 0. We'll set jump height equal to, let's see, what's 12 will probably be good, and we can play around with those later. And while I'm here, I'm going to create a gravity variable. I'm going to use, I think, just like 1, and we'll see how that plays. We'll do 0.9. We'll see how that plays. Those 3 that I just added, or really these 2, jump height and gravity, are how you're going to control your player movement. So if you're following along and you don't like the way the jump works with the values I just added, those are great places to change and make it your own. But so we'll say yChange is equal to negative jump height. And then what we need to do is we need to add some code that's going to actually change the player's Y position based on yChange. So what we'll do is we'll say if player Y, so the current Y position of the player, and we'll say plus Y change. So that's in the next scan how much the player's position is going to change by. That's Y change. And if those are less than the total height of the screen minus, we'll say 30, which is the player's size. So remember the coordinate system. All we're doing here is checking to see if the player would still be on the screen. And if they would be on the screen, even going downward, then what we'll do is we will just change the player's position. So player Y, and we'll just say plus equals Y change. Okay, and that's all we have to do. And then what we'll do to make gravity, if you think about gravity as like parabolic, every scan you want to add more gravity to it. And so the longer you're in the air, the more gravity is going to affect you downward. And the way we affect that is we add gravity every second that Y change is going on. Okay, and then what we'll do is an else. So this is what do we do if we've calculated that the next move would be off the screen. All I'm going to do is set the player Y position equal to height minus 30. And so this should be a cool little like sitting on the bottom of the screen effect. And hopefully when I run this, if we press the space bar, we'll get like a jump. Yeah, and it's cool. And you can jump multiple times. You can jump north off the screen if you want. And this is really cool. You can see now if there were obstacles flying through, we would have to control our jumps to get through the obstacles. So this is really cool. We got the bases of it. And now let's go ahead and add just the flames to the jetpack. I know it's kind of like a silly thing, but I think it'll really make it feel more fun. So I'm just going to call global Y change. You could absolutely pass Y change into the function. Some people would recommend always doing it that way and not calling globals. You can do that if you want. I'm going to do it this way. And if you're really gung-ho about Python, you probably don't need this tutorial video anyways. So, okay, if Y change, and what we're going to say is if it's negative. So a little bit confusing, but we have talked about, actually, let me just put pass in here and show you. We've talked about the coordinate system a little. This is 0, 0. So as you go right, you get larger values, and as you go down, you get larger values. So actually, when you're going upward, that means Y change is negative because it's subtracting from your current Y coordinates. So that's why we're doing if Y change is less than 0. And if Y change is less than 0, why don't we do this? Let's draw some red flames and then some like yellow lines inside of them. And I say flames, but the thing is so small that we can just do pygame.draw.rect and we'll put them all on the screen. And now I'm going to add a couple more colors up to my color library. I'm going to add red and I'm going to add yellow. And red, if you're familiar with the fact that it's RGB, is just 255255, and then yellow, you got to know a little bit of color wheel here, but yellow is 255255. So I think I misspoke. Red is 25500. Yellow is 2552550. But that gives me two more colors to use. So I'll make this flame red. And then we're going to make it a rectangle. So we got to put that on the screen. And we're going to make everything relative to X position. So if you're thinking about where the jetpack was, it was at this X pos minus 20. But now we need to scoot it a little bit further down. So we need it to not be as high as the jetpack. We want it to look like it's coming out of the bottom of the jetpack. And to do that, we'll just say Y pos plus 29. So that's like the exact bottom edge of the jetpack. And let's give it a width of 7. So it's only like about half the width of the jetpack. And then 20. So that's how tall it'll be. We will make it solid now, like a flame, and we'll give it a little rounded edge of 2. And then let's go ahead and copy that whole thing for making flame 2. And I think once you start, actually we don't need to be that indented, this will work. Okay. And for this second one, all I want to do is just scoot it to the right and everything else can stay the same. So instead of minus 20, it'll be minus 10. Let's go ahead and check it out. We should be getting two little, yep, whenever I'm going up, I get these two little red rectangles. That's cool. I think to make it really clear that that's like supposed to be fire, you could add yellow. You could add orange if you wanted, but I'm going to just add little yellow stripes inside of each of them. So I'm going to draw that on the screen. I will make it yellow. And then let's put it in X position minus 18. So we'll put this just a little inside of the red rectangle, and then we'll put it a little bit below. And then instead of being 7 wide, we'll make it 3 wide, and instead of 20 tall, we'll make it 18 tall. And still 0 and 2 should be fine. And let's do the exact same thing for Flame 2, and then I swear this will be the last time you have to watch me try to draw stuff onto the screen creatively for this tutorial. I don't know if I promise that. But okay, now we have this really cool little red and yellow like jetpack effect anytime we're going up. I love it. It's perfect. Okay, so the next thing, the thing that's really missing here is obstacles. Like, what are you dodging? What's the purpose of the game? And to do that, I'm going to start by coming up into my variable library, and I'm going to create a list that I will call obstacles. And actually the list that I'm going to use here is just going to be a list of X coordinates, okay? So to start, I'm just going to grab 5, and some of them are actually going to be off the screen, because if you think I have a width of 900, but what I'm doing is I'm setting up my game to no matter what, when you start it, I know that it'll be playable right away. So these are some reasonable distances, and I'm just going to initialize 5 obstacles right off the bat. But we want a lot of the stuff in this to be randomly generated. So like I want the heights to be random. I don't want to have to, as the game creator, go through and create like 1,000 different obstacles as you play the game and preset how it's written. You can if you're into that, but I'm going to import the random module so that we can use that. Okay, so obstacles, and then I'm also going to create a variable that I'll call generate places. Okay, so what this is going to say is in the very beginning, if it's time to generate places, and we'll use this when we restart as well, run some code once before drawing anything onto the screen. Run some code to actually create where those obstacles should be. So what we'll do is right above we drawing the player, and we'll draw the obstacles in a function as well. We'll say if generate places. So we're checking, and the way we're going to make this self-sealing is at the very end of this for loop, we're going to set that variable generate places equal to false. Okay, and so what I'm doing is I'm going to put a whole bunch of code in here that's going to run exactly once when the game starts up, just so that we randomly generate some. So what it'll be is for I in the length of the list we just made, that's obstacles. Okay, and so that's going to check how many obstacles there should be by using the obstacles list. We're going to make another list that I'll call Y positions. So let's just come up here and we'll make an empty list, Y positions. Because to draw those obstacles, we need a list of X and Y positions that we can use. So if generate places for I in range length of obstacles, we're going to do Y positions dot append. So it's going to go through that list and do this once for each obstacle. So you have the X position that we set, and then it's going to go through and get it a Y position. And the range of Y positions we want to be able to use are basically anything that'll be on the screen. So we'll do random.randint, and then you give it a range of 2 integers to select from, and I'll say 0 to 300. And you'll see why, even though the height is 500, we have to be able to have a reasonable gap for you to fly through. So you don't want the top barrier coming down to 400 and then not having enough room for your player to get underneath the top barrier. So we'll say just append a variable 0 to 300. You can play with that range if you want. But basically what we did is we just came through and we made a list of X and Y positions, okay? And so now underneath player, we're going to make another list or another function, marbles in my mouth, that we'll call draw obstacles, okay? And draw obstacles, we're going to want to pass in a few things. We're going to pass in the obstacles list that we just made, and we're actually going to pass in the Y positions as well, and we're going to send in the player, because what you'll see in here is I want to use this draw obstacles list function. I want to use it to create collision detection between the player and every obstacle, okay? So we'll do draw obstacles, and then I'll just shorten them a little, Y pause, and then play. So again, I don't like using the same exact, you need the letters D, E, F. I don't like using the same exact variable names inside of my functions, just to make it clear if you're dealing with a variable or a local. Okay, sorry, global or local. All right, now inside of the draw obstacles function, let's go ahead, and it's another for loop for I in range, and that'll be length of obstacles. So OBS, and let's see. Oh, I put a T on there. Very nice. For I in range length of obstacles, what do we want to do? First, let's go ahead and create a local variable that we'll just call y coord, and we will set that equal to y position at I. So now we have a just a local variable that is just saying what the position at y is, and then the x position is just going to be obstacles at I. So let's say top rectangle, because if you're picturing like flying through two obstacles, you're going to have a top and a bottom rectangle. So we'll say top rectangle is going to be pygame.draw.rect, and we're going to put it on the screen, and let's make it gray just so it's clear what's going on. And its x position is going to be obstacles at position I. And actually, we're just muddying things up by y coordinate, y position I. No, that's okay. We'll leave it. So this is x position, and then the y position that we want every rectangle to start at, if you think about, is going to be the top of the screen. So it's going to be 0. And then we'll go with 30, and then we'll have it go down until it gets to the y position. So that's going to be its height. Okay, and I think that'll look pretty good. So then let's decide on like the design elements of it. How, if we want to be solid, I think we should make it solid. And I guess actually we don't need to round this one. So actually, if you don't want to round it and you want it to be solid by default, that's all you have to draw. So let me just see. PyGame int is not iterable. I in range length of obstacles. Oh, it's because down here in my generate, this is supposed to be for I in range length of obstacles. That's why I don't like to write too much code without running it once or twice, because you don't want to have to go back, 20 times to, you don't want to have to go back 20 times to fix your code. So let's see, what are we getting? Draw obstacles, y positions, player. Rect argument is invalid. Why is it invalid? A little troubleshooting never hurt anybody. We've got x position, y position, width, and then height. And height is y position. That doesn't sound invalid. Oh, it's because we named it obst and not obstacles. I think. Apparently not. Okay, we called this y coordinate, and we called this obstacles I. You got to be really careful that you're using the actual variable names that you created. So there you can see we're getting the first two, which is nice. And if I run that again, it should be, yeah, it's changing. So it's randomly changing. But what we need is we need a bottom rectangle that is going to be far enough away from the top rectangle that you could pass through the space like while flying. So let's go ahead and just make a bottom rectangle. I'm going to copy everything from the top rectangle, but what we're going to be changing is like the y position that it starts at. So instead of starting at 0, we're going to want to use that y coordinate variable that we used. And this time we want to scoot it down. And so I'm going to move it down by 200. It might seem like a pretty big gap, but actually while you're playing it, especially depending on what like jump variables and what speeds you set up, 200 can still be pretty challenging. And this sort of spacing is what you can change around to have more of a difficulty if you want. But we'll still make it 30 wide, and then we'll make it finish at whatever the height of the screen is. And then we'll subtract out the y coordinate plus, so we'll do height minus, and then the y coordinate, and then we'll just scoot the whole thing down some. So we'll do y coordinate plus 70 just to get it all the way to the bottom of the screen. So if we look here, Yeah, okay, so we get this nice like gap, and you can see just with the jump that we've set up here, and again, if you've been changing the variables, you may want to tweak it up or down, but for me, this is going to be a challenging gap for the player to get through, but definitely still doable. Okay, so that's pretty cool. Why don't we make it look a little bit better? I know I promised you wouldn't have to spend too much time looking at my stuff, but let's make rounded rectangles on the top of them that make it look a little bit more like those Mario style like pipes or tubes that you go down, that you go through. So it's going to be pretty simple. We'll do this pretty quick because I know this isn't the essence of what you're here for. Pygame.draw.rect, put it on the screen, make it gray. Let's move it back just a little from where that first one started, and then all this for this one we're going to do y coordinate minus 20, right? So it doesn't need to be the whole height now. We just want it to be something that starts really close to the bottom of the pipe, and then we'll make it 36 so that it goes a little bit past on both sides, and then we'll say 20 for height. And then we will make it solid just like the other one, but we'll round it off, so we'll make it 5, and that'll be top 2, and then let's do bottom 2. And honestly, this little piece I'm doing here stylistically is one of the best places to play around and make it your own. Okay, so we're going to use y coordinate and add 200 for this one, still 36, 20, and 5. Let's just take a look at that. All right, I think that looks really good. I think now it just looks a little bit more fun. It looks a little bit more like you might expect if you're trying to rip off Flappy Bird. One more thing I don't think I did, but we can do it just so that every time you're opening this up, you might see at the top banner, PyGame window is what it says. That's a really easy thing to change. Probably should have done this at the beginning, but oh well. Pygame.display.setCaption is all you have to do, and you just put a string in here, and I like calling mine Flappy Space, so we'll call it Flappy Space. Okay, and so now when I open it up, you'll see it just says Flappy Space right there, and if you want to bring in a little icon to really make it your own, you just do pygame dot and then set icon, and that little snake will get replaced with your icon, but I don't care that much. Okay, so now we're drawing the obstacles, we're doing it in a function, and it looks really good. And so I think the last thing that we should do is we should create another variable, and let's call it Gameover. And to start, it's obviously going to be equal to false. You haven't lost the game yet. And inside this function, I said I wanted to use it for game over checking. Let's just call the global game over, because that way it'll mean we're talking to the master variable, and we don't have to return anything. And let's add something here. Let's add if the top rect dot collide rect, and if the top obstacle collides with the player, or the bottom rectangle collides with the player, okay, then we're just gonna say you lose. And the beautiful thing about the way we wrote this function is that's all gonna check for every obstacle. So you don't have to say like, oh, the closest obstacle. If you hit any of the obstacles on the screen, which really, you know, if you're playing this game is only possible with whatever one's closest to you, like you're only ever at risk of hitting one obstacle. But this is sweet. Like this draw obstacles thing is going through every obstacle and checking for collision, and we're going to set game over equal to true. Now game over doesn't do anything yet, but we'll get to that in a second. The next thing we want to do is we want to move those obstacles, right? Because that's how the game is played. So we'll come down to where we created the height checking, and underneath that, let's create a little loop, because that's where we handle player's movement with Y change, right? And we'll handle the obstacles X movement. So we'll do for I in range, and then length of obstacles. Obstacles. And what we want to do in here is say if not game over. So once the game is over, we want those obstacles to stop moving. But if the game is not over, then obstacles at I are going to be minus equal, and we'll just create a new variable called speed, okay? So up in our variables, let's call it, let's just make it 3 to start, but that's another great place to play around with. You'll see it gets way more difficult if you make that a much higher value, and it gets really, really easy if you make it a low value. But actually, making like a variable speed during the game, so like if your score is getting higher and higher, you increase the speed. That could be one really fun way to add like progressive difficulty if you're into such things. For now, I'm just going to do it that way. And the cool thing about this is that's all you have to do to get moving. But what you'll see right away, if I can dodge 5 of these, I am now in the clear because we're not deleting them out of our list, and we're not adding new ones to the right side of the screen. So to handle that, let's go ahead and say if obstacles at I is less than -30. Okay, so that's the point when they're completely off the screen, right? They're 30 wide, and if the X position gets to -30, take them off the screen. We're going to do obstacles.remove first, and we're going to get obstacles.I or at I out of there. Okay, but then what we're going to do is remove it from the Y positions as well, because those two are kind of a pair. They're a pair of coordinates. And so we'll remove Y positions at I. And then the next thing we want to do is we want to add some points. So it's going to be obstacles.append. And if you're not familiar with Python lists, then you maybe aren't familiar with remove and append, but hopefully you have enough object-oriented programming that you're familiar with what I'm doing here. But what we'll do is we'll append a value that is going to be a little bit of randomness, but we don't want to make it too crazy far off, because what we had when we started them out was we spaced them by about 300 pixels. We don't want the game to become unplayably difficult. So we'll append to the end of the list. We'll say wherever the last obstacle is, plus 280 up to wherever the last obstacle is. So that's the obstacles -1. We're referencing the last obstacle on the list, and we're saying put the next obstacle between 280 to 320 away from it. Okay, so if this little bit doesn't make sense to you, we're randomly creating the new obstacle, but we're tightening its range to only within about 40 positions, 40 pixels. And then we'll also append to the Y positions, but this one's going to be a little bit simpler. It's going to be just the exact same that we did when we initialize them up here. Okay, so I'm just going to copy that. Anything between 0 to 300, and we're going to let the game create that. And now let's introduce an element of score. So let's do score plus equals 1, and we're going to have to initialize that variable up in our library just like always. Score is going to start out equaling 0, but let's say the more obstacles you can get to disappear off of the screen, the higher your score. Okay, so let's go ahead and check that out just to make sure it's infinite. So once we get to 5, hopefully, yeah, we see 6. Oh, I hit the pole, and so I can still jump, and which we'll change in a second, but you can see the obstacles stop moving, so that's pretty cool. Let's go ahead and go to the jump logic, this K space, and add and not game over. Okay, so now when I hit something, it'll stop the game, but I can't jump anymore, you know, so that's cool. That's the game over really taking effect. And we've added scoring, but we're not showing score anywhere. So how about we do two things that'll make this a little bit cooler. Let's add a high score variable as well. High underscore score, make that equal to 0. And let's just put the score and the high score on the screen somewhere. So what we haven't done yet in this game, and you're going to want to do this in almost every game, I just haven't talked about it till there was a need. You want to set up the ability to put text on your screen, and you do that by creating like a font variable. And I'll literally call mine font, but it's going to be pygame.font.F font. And then I usually just use Free Sans Bold. If you're familiar with the channel, you know that. It's one of the ones that's built in with Python, so I don't have to go out and get a TTF file, but you definitely could bring in a font file, put it in your file directory, and that's how you get like a custom font in the game. Okay, and then you just give it a font size, which I'll say it'll be 20, but that's all we need to be able to come down to the very bottom, and I'm just going to say all the time, so I'm not going to make it conditional on anything. I'm just going to say score text is equal to, and now you do font.render. So that variable that we defined before as a PyGame font, you use this built-in tool render, and then you give it the text that you want. So it's going to be the word score plus a string conversion of the score. So score is an integer value. That's how we're able to increment it and add it. But you can only concatenate or combine string values by converting everything to a string. Okay, so this is going to give us the text that just says, here's your score. And true and white. So we're going to make this text white. And the next piece to get it to actually show up on the screen is going to be screen.blit, the text that you just defined, score text, and then give it an X and Y coordinate. I'm going to say 10 and 450, get it kind of in the bottom left corner here. And let's just check and see. As stuff goes off the screen to the left, the score should start updating. Yep, so you could make it, I think this is kind of how actual Flappy Bird worked. Anytime an obstacle passes like the player, you get a point. You could just update that by, instead of saying like when a obstacle goes off screen to the left, update the score. You could just update the score. You could update the score when an obstacle passes the player if you want. I kind of like just using our checker to see if it's off screen to the right. But then we'll add just basically this exact same thing, just high score text, high score plus high score. And this is going to be a little bit more useful once we've actually like added restart code and you can play it multiple times. But I'm going to put it right underneath the regular score. And if you think about what high score is basically if the score is greater than whatever the previously listed high score was equal to, just set high score equal to score. That may seem silly right now because we haven't put restarting in there yet. And so what you'll see is like, well, score and high score are going to update at the exact same time. And actually it looks like I forgot to, yep, you got to change this to high score text as well. High score text. So they're different variables, but until we can restart the game, high score and score are just going to always be the same variable. So with that being said, let's add some restart code. And what better than to reuse the spacebar? Now you may get into a position because you're pressing the spacebar all the time to jump, where if you hit the spacebar right after dying, it's going to immediately play again. That might not be ideal for you, so you may want to use a different key. I'm just going to do it this way. If you press the spacebar and it is game over, instead of jumping, what I want to do is I want to basically set everything back to how it was when the game started. I want the X position to go to 225. I want the Y position to go to 225. I want Y change back to 0. So this is basically restart code, and you could create a function if you wanted to. I think since it's not too much, I think just putting it right in here is actually the easiest way to go about it. So then we want generate places to be equal to true, so it'll give us a new randomly generated board. And what else? We want the obstacles list, because by now the obstacles list is going to have changed a whole bunch. So we want, actually I should have copied basically all of that stuff. We want the obstacles list back equal to what it is. We want Y positions to be empty again, because those will get created during the restart. And then we want score to be equal to 0, and then we want generate places to be equal to true. Oh, I already said generate places. Okay, last thing, we just want to set game over back equal to false. Game over equals false. There we go. That's pretty sweet. So now if I press space after dying, let me just get a few points here for a score first. So let's say high score. And you'll notice one thing I didn't clear out in the restart logic was the high score. Okay, so I died, I pressed space again, and I started again. And now you can see it held on to high score. And as I score these new points, it's not updating. So that means our high score is working. Okay, and I'm not going to play this too much because we got a little more work to do. Why don't we add just briefly some text down here where we're adding text. So right above score text, we'll say if game over. And let's do what I'll call game over text, and that's going to be equal to font.render, and I'm going to give them instructions on how to restart, because the only reason we knew it was press restart was we coded it. So we'll say game over, space bar to restart. Okay, and let's put that, so true and white, and let's do screen.blit. I believe blit stands for block transfer, but it's just basically, it means draw something onto the screen. So let's put this pretty close to the middle of the screen. So it's going to be screen.blit, Gameover text, and then it needs coordinates, and we'll say 200, 200. And let's just take a look at that. So I'm going to go ahead and die real quick. Shouldn't be too hard. I'm not that good at video games. Bam, game over, spacebar to restart. Works for me. That's pretty cool. Okay, so two things that I think are really going to take this game over the top, really make it like next level. Let's add a moving background of stars. I mean, that's going to make it so cool and so clear that you're in space. You can already see you have a really good game, and if you want to be done with the tutorial, like and subscribe because you've made it this far, and I hope you've gotten some use out of it. But we're going to take a few steps to make it really the extra mile, a super fun game. And to do that, I'm going to, similarly to the Y positions, I'm going to make an empty list called stars. And down where we initialize the obstacles, I'm also going to initialize some stars. So the cool thing is I can pretty much plug into pieces of code that I already have written and do all of this randomly generated star creation kind of in the same spot. So let's go ahead and say, I'm going to create a variable in here. Just if I want to change how many stars are on the screen, I can just change it right here. But it's also totally valid to put it up in the variables library. I just think I might want to tweak that, and having it right here might be easiest. But what it is for I in range total, so we decide how many stars we want to make. And I'm just going to say xpos is equal to a random integer. And this is really cool. What we're doing is just initially, when it's time to create new stars, we're just going to randomly select 100 positions, random.randint. We're going to select 100 positions that could be anywhere on the board, width to height, and we're going to make a list of their coordinates. So stars.append, and then we will say at X position, Y position. So we're making this really cool, just list of coordinates, and then y position generate places equals false, and then we're going to come down, we're drawing the player and we're drawing the obstacles, and I'm actually going to put draw stars above those. And the reason I'm doing that is, even though collision is going to mean nothing, like if a star collides with an obstacle or the player, it's going to mean nothing, but I want to create this perspective that the stars are actually behind everything, you know? And so we're going to want to draw those first so that stars aren't over the player when the two cross. Stars should be behind the player, behind the obstacles. And to create order of drawing things, that's the order that they go when you read top to bottom in your file. So we'll do draw stars up here, and we're going to pass a few things in. We're going to pass our, actually just one. We're going to pass in our coordinates, and we come up to where we've been creating functions. And let's define a function called draw stars. And this is going to be really easy, but it's going to add so much to the game. Okay, so what we want to do is, let's call in the global of total. You could pass it in. Do what you want. For I in range, total -1, so we don't want to go out of range. And for I in range, total -1, PyGame.draw.rect onto the screen, a little white rectangle at position stars I, and then since that is a list of coordinates, you have to give it a second value. So we're going to say I0, which is going to go through your list of coordinates and take the first piece, and then the Y position is going to be stars at I, but then position 1. Okay? And then we're just going to say, let's make it 3 wide and 3 tall. And let's go ahead and we'll say we want it to be solid, but let's round it off by 2. So it's basically a circle at this point. If it's 3 wide and 3 tall and each corner is rounded by 2, it's basically a circle. But I did pygame.draw.rect. I don't know why. Maybe I'm just in a drawing rectangles mode. But then let's go ahead and say stars I and then 0, so the X coordinate, and let's subtract half So this is star speed. You could make a new variable if you want to and call it star speed. Since this is just like a nice background effect, I'm gonna go ahead and just make it a constant half pixel, and they'll just make them slowly drift to the left. It's gonna look really cool. But what we have to do is also to make it infinite and make it to where if they do go off screen, we make a new one. Check to see if the X coordinate is off screen to the left. I put an O instead of a 0. Nice. So check if your X coordinate for your stars is off screen to the left, and if it is, we're just going to make a new one. We're going to say stars I 0, and we don't even have to delete it. I know that's how we did the obstacles, but what I'm going to do is instead of deleting it, I'm just going to repurpose it. I'm going to move every star that goes off screen to the left by 3, and I'm going to put it off screen to the right by 3. And then I'll give it a new Y position. So it's not a boring, like constantly repeating landscape. And so the Y position will be random.randint 0.height. And just to be clear on why when we make this stars list, I put them in this way with square brackets rather than with parentheses, is because parentheses is going to make it a tuple, which is a Python type of variable that cannot be modified. So you wouldn't be able to do this individual manipulation of X and Y coordinates if it was in as a tuple. Technically, we put it in as a list so that we can modify single pieces of it just like that. Okay, and then let's return the stars. So Shift Tab, take it back here, and let's actually just say stars equals Drawstars. And I believe if we did everything correctly, we should have a really cool just starscape moving across the screen now when I boot this up. So let's see if I can survive long enough. Uh-oh. Takes no positional arguments but was given one. What are we talking about? Oh, I didn't tell them that they were going to be receiving a stars thingy. Let's see. Draw player, player X, player Y. Invalid syntax. Uh-oh. Did I delete something? Player equals player X, player Y. Gosh, I don't think so. Did I delete? Oh, I put a space in there somehow. Nice. Really cool, Pete. We're getting a lot of errors here. Tuple indices must be integers or slices, not a tuple. All right, well, what's going on here? Let's take a look. Stars equals draw stars. Stars. Stars is a list. Stars is going to be a list of lists with these X and Y's. We pass them in here. We use them. Oh, you got to put commas in between everything. Here you go. You guys got to see a little bit of fun troubleshooting, but you can hopefully see, like, I think that adds so much to the game. It's like clear you're flying through space now. The stars are moving to the left, so you get this really cool like 2D dimensional effect of just like eternity, and you can run through this game forever, and the board's going to keep changing, which is really cool. The obstacles are changing randomly. Let's go ahead and die. Okay, so the stars keep moving. How cool is that? It's like you're flying through space. And then I press space and restart. You can play again and again. This is really fun. Let's do one more thing that I just think is awesome for games, and let's add some music, okay? And this is so easy. I recommend, if you're not sure whether or not you can use a certain type of music, especially if you plan on like sharing with people or publishing this anywhere, go to like the YouTube library. They have a huge library of just royalty-free music. So I grabbed one just called Mysterious Strange Things off of YouTube. But you can grab any file you want, and we'll just say music right up here. And to use music in PyGame, it's pygame.music. .init, just like we initialized PyGame, initialize the, or not music, it's called mixer. Sorry, it's been a long video. Pygame.mixer.init, and then pygame.mixer.music.load. And here you actually tell it what, .music. Here you actually tell it what file to look for. And as long as you've dropped your file, so I have an MP3, as long as you've dropped it into your game folder, your project folder, it's going to show up when you start typing the name. So mine's Mysterious Strange Things. Make sure it's in quotations, so like a string value. And then the next thing I'm going to do, pygame.mixer.setVolume. You don't actually have to do, it's pygame.mixer.music.setVolume. You don't actually have to do this step, but volume of 1 is pretty loud. So I'm going to set it down to 0.2, pygame.mixer.music, and then .play. So what I just did, this last one, you actually want to take this line and put it wherever it is that you want the music to start. So I'm just going to have it start when you boot up the game. So I'm going to put it there. And then I'm going to have the music restart when you restart the game. So I'll also put it down here inside of the restart logic, pressing the spacebar. And let's take a look at if we got it. Okay, so you can probably hear, another reason I put it at 0.2 is so I wouldn't be drowned out showing it to you guys. But you can hopefully tell, like, that's a pretty fun little spacey, funky song, totally for free on YouTube, free to use. And it really adds another step to the game. So, like, it's the same exact game we had before music and before we had this, like, star background. But it went from, like, a fun little computer app to, like, a legit game by adding those two. So that's everything you need to build your own version of a Flappy Bird style game in Python using PyGame. I hope you found it useful. If you did, please like the video, subscribe to the channel. It helps me out a ton. I've really been appreciating all the comments, all the support I've been getting. I'm trying to crank out high quality content, and knowing there's some interest in it really helps me out a lot. So thank you so much for watching it. Thank you so much for supporting. If there's any questions you have about anything you saw in this or want to see something specific in a future video, just let me know about it in the comments below. I'll respond as quickly as I can. I really appreciate the support. Again, a like on the video, subscribe to the channel is the best way to show your support. Leaving a comment letting me know you like it is great as well. And I really appreciate it. Good luck with your code, and thanks for watching. Thanks. Bye.